Part 1. What exactly is a tornado? At its core, a tornado is a rotating column of air that extends from a thunderstorm to the ground. It's invisible until it picks up dust, debris, or moisture, forming that familiar funnel shape. Tornadoes come in many sizes, from narrow rope-like twisters to massive multi-vortex monsters over a mile wide. Despite lasting only a few minutes, their energy output can rival that of a nuclear bomb. Part 2. The birth of a tornado. Tornadoes are born inside powerful thunderstorms, particularly supercells. A supercell is a storm with a rotating updraft known as a mesocyclone. When warm, moist air from the Gulf of Mexico meets cold, dry air from the Rockies or Canada, it creates instability in the atmosphere. This clash of air masses, combined with wind shear, where wind speed and direction change with altitude, sets the stage for rotation. Once the rotating air tightens and stretches downward, the tornado is born. Part 3. Measuring tornado power. The enhanced Fujita scale. To understand just how powerful a tornado can be, scientists use the enhanced Fujita EF scale, which ranks tornadoes from EF0 to EF5. EF0 tornadoes have winds of 65 to 85 miles per hour, enough to break branches and damage roofs. EF3 tornadoes can reach 165 miles per hour, tearing apart houses. EF5 tornadoes? They exceed 200 miles per hour, capable of leveling entire towns. It's not just the wind speed. It's the flying debris and pressure changes that make these storms so lethal. Part 4. The science of tornado strength. A tornado's power comes from angular momentum, the same principle that makes figure skaters spin faster when they pull in their arms. As air rushes inward toward the tornado's center, it speeds up dramatically. This concentrated rotation creates incredibly low pressure inside the funnel, sucking up debris and amplifying the wind speeds. The tighter and more stable this rotation becomes, the stronger the tornado grows. Part 5. The most powerful tornadoes on record. The most intense tornado ever recorded hit Bridge Creek, Oklahoma in 1999. Its winds reached an unimaginable 302 miles per hour, the highest wind speed ever measured on Earth. Towns were obliterated, and debris was thrown over 60 miles away. The 2011 Joplin, Missouri tornado was another catastrophic event, killing 158 people and causing over $2 billion in damage. These disasters remind us that nature's fury can reach levels beyond human control. Part 6. The incredible energy of tornadoes. It might surprise you to learn that an average tornado only lasts about 10 minutes and spans a few hundred yards. Yet, the energy released during that time can exceed that of several atomic bombs. The sheer power packed into such a small area is what makes tornadoes unique among natural disasters, short-lived but intensely destructive. Part 7. Tornado dynamics. What's happening? Inside. Inside a tornado, the physics are extreme. Air pressure drops sharply, sometimes by more than 100 millibars in seconds. This pressure difference can make buildings explode outward. The air moves in tight spirals around the core, with the strongest winds often occurring just outside the visible funnel. Some tornadoes even contain smaller subvortices spinning within them, each capable of causing localized destruction. Part 8. Why tornadoes sound like freight trains. People who've survived tornadoes often describe the noise as deafening, like a roaring freight train. That sound isn't just the wind. It's the violent interaction of air, debris, and pressure waves. The roar gets louder as the tornado approaches because the funnel amplifies the sound waves, much like a jet engine ramping up power. Part 9. The role of supercells. Supercells are the most dangerous type of thunderstorm because they have sustained rotation. The updraft in a supercell can reach speeds of 100 miles per hour, and when this rotating column of air tilts vertically, a tornado can form. These storms can produce multiple tornadoes, one after another, in what's known as a tornado outbreak. The US experiences more of these than any other country, especially across Tornado Alley. Part 10. Tornado Alley, the perfect storm zone. Tornado Alley stretches across Texas, Oklahoma, Kansas, and Nebraska, a region where the right ingredients come together often. The flat terrain allows warm, moist air from the Gulf to mix easily with cool air from the north and dry air from the west. This creates explosive storms that can spin up deadly tornadoes. However, in recent years, scientists have noticed that tornado activity is shifting eastward towards states like Mississippi and Tennessee. Part 11. The human impact. Behind every statistic are real lives. Tornadoes can destroy entire communities in minutes. Survivors often describe it as total chaos, walls collapsing, debris flying, power lines snapping. Recovery takes years, and even smaller tornadoes can leave emotional scars. Advances in early warning systems have saved thousands of lives, but the human cost remains staggering. Part 12. Can we predict tornado strength? Meteorologists have made progress in forecasting tornado potential, but predicting exact strength or location remains extremely difficult. Doppler radar helps detect rotation in storms, giving residents valuable minutes to take shelter. However, no technology can yet pinpoint when a funnel will actually touch down, or how powerful it will be. Tornadoes remain one of nature's great wild cards. Part 13. The myths about tornadoes. There are plenty of tornado myths that can be deadly. Some people believe opening windows relieves pressure. It doesn't. Others think rivers or mountains protect them. They don't. Tornadoes can cross rivers, climb hills, and even move through cities. The safest place during a tornado is always an interior room on the lowest floor, away from windows. Part 14. The aftermath and debris field. After a tornado passes, the landscape looks like a war zone. Trees stripped bare, power lines twisted like spaghetti, and debris scattered for miles. The damage path can tell scientists a lot about the tornado's power and movement. By studying the debris pattern, researchers can estimate wind speeds and improve future building designs and safety measures. Part 15. Tornadoes on other planets. It might sound strange, but tornado-like storms happen beyond Earth. On Mars, dust devils, mini tornadoes, sweep across the planet's surface, though they're much weaker. On Jupiter, storms like the Great Red Spot dwarf any Earth tornado spinning for centuries. Compared to these cosmic storms, Earth's tornadoes are small, but their intensity per square mile is unmatched. Part 16. The future of tornado research. With advancing radar technology, drones, and AI, scientists are getting closer to understanding tornadoes in real time. Drones can now fly near tornadoes to collect pressure and wind data. Machine learning models help predict conditions that lead to outbreaks. The goal is clear: to extend warning times and reduce fatalities. Every storm studied brings us closer to unraveling the mysteries of these violent twisters. Tornadoes are a terrifying reminder of nature's power, unpredictable, unstoppable, and capable of changing lives in an instant. From the moment warm air meets cold to the last piece of debris settling on the ground, each tornado tells a story of science, chaos, and survival. So the next time you see a thunderstorm forming, remember, inside those clouds could be one of the most powerful forces on Earth. Stay alert, stay safe, and keep respecting the raw strength of nature.